An AC machine has not changed.
No.
Has the AC system on a car changed?
A lot.
A ton. So that's where these guys are getting into trouble. So what we did with this, everything's got a water speed on it.
Yeah.
What should I do the car? Refrigerant type, oil, capacities. Is it standard compressor, clutch cycling, variable displacement, electronic control, heat pump? Because you got all of that you're dealing with now, not just a regular compressor. Air-cooled or liquid-cooled condenser. Does it have a heat exchanger? So the whole configuration we tell you to start. And that screen we were just looking at, every time we have you go in and out, we walk you through that you're supposed to take and hook the vacuum pump up and suck the hoses and manifold into a vacuum. This helps purge it between refrigerants. So you've got one setup and you just change couplers for different refrigerants, which means they come out with another refrigerant and they're looking at some. All you gotta do is buy another pair of couplers and the software change, you're there. So you don't have to buy another machine. Hook everything up, follow the instructions. There's the entire AC system, high, low, late. There, liquid and vapor all labeled out for them. Anywhere you see the OBD2 symbol, that's coming out of the car from the VCI. Anywhere you see the gauge symbol, that's live readings from the temp probes or the gauges. So you can now compare what the car thinks is happening to what really is, make sure that matches up. Then we go in depth. Old days, we had 2-3 pound AC systems. You had a lot of forgiveness there. Now they're sub 1 pound, half pound. Now there's a nice edge to how performance is, and you don't have a way of looking at it. Just pressures won't tell you. So here's what we've got on here. We took a thing out of the residential and industrial HVAC world. So there's my pressure, my low pressure is 28.9. At that pressure, the vapor saturation point, when it does the state change in the evaporator, is at 29 degrees. The temperature coming out of the evap is 54. That means that evaporator absorbs 25 degrees heat in the cabin. When I get to the high side, the same thing with liquid saturation point, I gave off 10 degrees to the atmosphere. So that I can actually see how the AC is performing and working to be able to get down to the limit. If you don't understand that stuff, touch the little touch point. That's helping you with where that superheat number should be. We can even go further, go to my little manual here. Enthalpy is what we're talking about. To help them understand what we're showing them and giving them access to. So that's information he hadn't had before. After that, go around, look at the system. We have other touch points. Now the other challenge they've got, right, besides poor performance and it's that clutch cycling valves or other stuff so you can identify it, you've got automatic temp control, right, rear, front, left. Difference is there. So we took the vent system and did the same thing. Your blend doors, your mode doors, where they're at, live readings from the temp probes. So now they've got all that information. Now we start to work on the car now that we've got a diagnostic and direction. We start them out, hook everything up like we said, do the vacuum. If we're on the same car, we can skip that. Now we're going to open it up and we're going to pull refrigerant into the sight glass area, which is backlit. And now the same thing we've done with tranny fluid, brake fluid, power steering or whatever, we can do with a refrigerant. And we can look at the condition. Are there contaminants, metal fragments? What color dye did the last guy put in? Because if I use green dye and I have a black light range for green dye, it will never light up yellow or red. So now I know what's in there to make sure I use the right light frequency to get there and bandwidth. So I'm able to look at that. Variable displacement compressors have a swash plate. Changes how they work. There's a $4,000 tool you can buy to unplug your compressor disconnect and hook to it and attempt to test that. Or you can go through OBD2 and do some testing. Compressor control box with connectors comes with this setup. I plug the proper cable into a T on this compressor. So I've got the OBD2 control still there, but my box in control. Now I can check voltage and resistance for the control valve and the compressor. Then turn around. Run the car 1700 RPM. Now, high side's going to be going up, low side's going to be going down. The compressor's reacting in duty cycle through the control valve, expansion and stuff. It should be lowering down as everything comes into sight. When the pressures reach their optimum range, this should be between 40 and 80%. So as it gets there, the tool will show you a highlight bar of that range. That green line needs to be in that bar. Otherwise, the computer's not controlling things right. So I'm testing the computer for reading and getting there. When it gets here and stops in a minute, or gets to that point here in a minute, the next light will light up, but the next thing it will do does have me reduce the car to an idle. Now the box takes over control of the compressor and will start it at a 20% duty cycle. Watch the pressures get to where they should and stable, then jump it to 30, then jump it to 40. So now I tested the computer here, now I'm testing is the compressor reacting like it should, and are the pressures happening and working. So I can actually test that variable displacement compressor or a heat pump if we're working with that, and know if it's actually operating like it should. Is the computer operating? Is expansion valves? Are all the components working? There's that highlight mark. There we're at the 20%. Pressures will get in range, then it'll jump and it'll lock it through. So we gave them a way to test the variable displacement compressors and heat pumps. We built in a dryer blockage test for them, where they're going to use their line temp probes either side of the dryer. The dryer should flow through relatively free. If it's got a temp drop, that dryer's got a restriction. It's playing expansion valve. So now they can test it, not guess at it, with the temp probe. We built in expansion valve or orifice tube tester, looking for a pressure equalization or looking to see if that superheat, right? I go in there, run the car, turn the blower all the way on high. Now I'm pushing more air over that evap. That superheat should raise temperature down, right? But the expansion valve should compensate and make it come back stable. If it doesn't stay stable, my expansion valve's not working. So I've got an actual test for that. So we built in all these system tests for them. Obviously we can do recovery. We do a nitrogen pressure test. Comes with a regulator to do a nitrogen bottle.
So this will recover too and suck out the system?
It will recover.
Oh, that's awesome.
But now here's the fun one I have. Everybody's got to have their own good dad joke, right?
Yeah.
I'm about to prove to you that your AC machine sucks, but not very well.
Yeah.
Let's go to vacuum. Hook everything up. Now, first thing we do different, you only hook up the low side. You put an independent gauge over on the high side. This way I'm making sure, because when I hook an AC machine, hook up both sides and do vacuum, great. I got vacuum right here by the low port. I got vacuum right here by the high port. I have no idea if there's a restriction of refrigerant trapped in between. Right. By doing this, I now see if that vacuum is getting all the way to the high. I know I'm really vacuuming the whole car. Now, we're going to get deep for a second. Put the seatbelts on. Step one. Why do we vacuum out the vehicle or an AC system?
Moisture.
Remove moisture. How do you remove moisture with vacuum?
It boils it out.
Huh?
It boils it out.
How do you boil it out with vacuum? You're right, by the way.
Time.
Huh?
Time.
No. Lower the pressure. Lower the pressure, lowers the boiling point. You're right. So, these guys all been told from this AC machine, 28 inches for 30 minutes. All right, it's a bigger one. Well, they've been lied to. First off, the correct way to measure vacuum is not in inches. The correct way in any studies you'll do, is microns. And your target is below 1,000. We put it at 500 here. Now, here's what we're talking about. Boiling points of water. At 28 inches of vacuum, you got water down to 86 degree boiling point. If you're in Phoenix in the summer, great. If you're in Wisconsin in the spring, you ain't doing shit. The reason you should be going to 1,000 microns, and the reason they say 28 inches for 30 minutes, they're hoping you're going to get down to where you should. But you don't know. If you look here, 28 inches of vacuum is 31,000 microns. We're wanting to be below 1,000. I go down there at 1,000, now I've got a boiling point of 0 or sub-zero Fahrenheit. So now I'm actually boiling water no matter what I'm at and getting it out of there. I can see when that happens. In fact, there's what it should look like, clean, dry system. That's a leak. That's what moisture looks like. Starts to hit it, boil it, comes up to the microns, goes down, finds another pocket of refrigerant and oil and water, boils it out, stabilizes out. So I can actually see the moisture being removed from the system and when it's truly dry. Again, these small systems, a little bit of moisture screws everything up and it doesn't work right.
What was this system list for?
$9,800, complete setup, cabinet, vacuum pump, recovery compressor, scale, which is also Bluetooth for charging and recovery measurements, vent probes, line probes, regulator for the nitrogen, all included in it.